Hi, good morning, students. Today's our topic is how to work out order from a given graph. And at the end of the chapter, I have given a link. When you click that, you can see the question bank of the chapter 2. Even I have sent the notes and the question bank in the email. So please try to do all these questions. So today's topic we'll just see. So for knowing today's topic, you have to remember the rate concentration graph of each order reaction. So we have zero order reaction, first order and second order. You have to know the shapes of each graph. For a zero order, it's a constant. You can see here, it's a horizontal line. For a first order, it starts from origin and it's a straight line. For second order, the shape of the graph will be like a curve. Now we'll see the questions. So here the decomposition of nitrogen oxide is given and the concentration and the rate is given. Okay, they are taking different concentration of N2O5 and finding out the rate. So we have to plot the graph, or in some cases they will give you the plotted graph, or now we'll study it as plotting the graph. So it's more good for you. So when you plot the graph, you have to see what shape you are getting. According to that, you will say the order of the reaction. So use the graph to determine the order of the reaction and deduce the rate equation for the reaction. That is the question. So you can see here, when we are plotting the graph, here they have taken the rate and here the concentration of N2O5 in the x-axis. When you plot the graph, you will get a straight line starting from the origin. So this shape is identical to the shape of a first order reaction. So how we write the rate? Rate is directly proportional to concentration of N2O5. And rate equals, in order to remove this directly proportional, what we do, we'll put K multiplied by concentration of N2O5, where K is the rate constant. So this is the rate equation for this reaction. I hope it is clear. So how we plot the graph? You have to take the values which is given to you, okay, and along the y-axis you have to take the rate, and along the x-axis you have to take the concentration and see which shape of graph you are getting. So this is equivalent to the graph of a first order reaction. See here, it's a straight line starting from origin. Now this graph also we have studied, that is concentration time graph. Here if concentration and time is given, you have to check for these graph. While you plotted this, if you are getting a shape like this, yeah, or if you are getting like this, it's a zero order reaction. If it is like this, it's a first order reaction. So you have to study the graphs, then only you can answer these questions. So we'll see another question. This is the concentration and time. This is for a zero order reaction. This is log of concentration and time. This is for first order reaction. And this 1 by concentration and time. This is a second order reaction. If they are giving you concentration and time, if the shape of the graph is like this, it will be a zero order reaction. If they are asking you to plot a graph with log of concentration of A and time, if you are getting this, it will be a first order reaction. So now we will see some questions. See, dinitrogen pentoxide decomposes to NO2 and O2 at relatively low temperature in the following reaction. The graph of concentration versus time, then concentration versus time, log of concentration versus time, and 1 by concentration versus time. So same like this, if they will give you the plotted graph and you have to see which shape is identical with this. Okay, so see here, all the values are given here. Time is given, concentration is given, log of concentration is given, 1 by concentration is given. Our aim is to plot 3 graphs, or maybe they will give you the plotted graph in your syllabus from the given graph. So mostly they will provide you the plotted graphs. You just have to see the shapes. So what they will do, concentration and time, they will draw one graph, log of concentration and time another graph, and 1 by concentration of and time another graph. So total 3 graphs they will show you. In this you have to identify which is similar to the above shown diagrams. So here in this case, the plot of log N2O5 versus time gives a straight line. So this is a first order reaction. So how you remember that? You have to go back to the shapes of the, if concentration and time, it's a straight line like this. If log A and time, it should be a straight line. If 1 by concentration and time, it should be a straight line. So when we compare this with these graphs, these two are not straight lines, only this one, that is the log concentration and time is a straight line. So the order of the reaction will be a first order reaction. And how we write the rate? Rate equals K multiplied by concentration of N2O5. So the order of the reaction is 1. Same like this, another question, 1,3-butadiene is a volatile and reactive organic molecule. We are giving again concentration, graph of concentration versus time, log concentration versus time, and 1 by concentration versus time. So again we have to see the shapes of the graph, and you have to compare it with the general graph which is given there for first order, zero order and second order. Then you have to find the order of this. See here, the values are given here. Maybe they will ask you to plot, or they will give you the plotted graphs. So here, when you see these graphs, see the first one is with concentration and time. This is log concentration and time. And this one, 1 by concentration and time. So when these three are compared, you can see here this is not a straight line. This is not a straight line, and this one, the last one, that is 1 by concentration and time, is a straight line. So we draw 1 by concentration versus time for second order reaction. So this will be a second order reaction, and rate equals K multiplied by concentration of C4H6 raised to 2. So the overall order of this reaction is 2.